All right, let's build unit circle real quick. So we're going to draw a circle in our XY plane. First thing we're going to do is go through and label all of our angles in both radians and degrees. So I like to do this in stages. Let's start here at 0 degrees, which is 0 radians, 90 degrees, which is pi over 2 radians, 180 or pi radians, 270, which is 3 pi over 2, and then all the way around, a coterminal angle with 0 is 360 degrees or 2 pi radians. Now let's put in all of our 45s. So here's 45 degrees. Pi over 2 is 90 degrees, so half of that would be pi over 4. And now we're just going to go around and we're going to count by 45s all the way around. So here's 45. 2 45s would be 90. 3 45s would be 135 degrees. Again, we're doing this in degrees and radians. So there's count. Think of it like you're counting apples or something. There's 1 pi over 4, 2 pi over 4, which we already have, 3 pi over 4. It's getting a little messy. 3 pi over 4. This guy here would be 4 pi over 4. Those 4's reduced. That's just pi. We already have that one. The next one, 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4. And then this guy would be 8 pi over 4, which of course reduces to 2 pi. Let's put in the degrees on all those. We're just counting by 45s. So there's 45, 90, plus 45, plus 45, plus 45, 225. Plus another 45. Plus another 45, 315 degrees. And then plus another 45 gets me to 360. Now let's put in all of our 30s. So we're going to go all the way around. We'll do it all in degrees first, and then we'll do all the radians. So 30 degrees plus 30, 60. Plus another 30 is 90. I already had that one. 120. Another 30. 150. Another 30 would get me to 180. Add on another 30, 210 degrees, 240 degrees, 270 I already had, 300 degrees, 330 degrees, and then back to 360. Let's put all those in radians. Remember, 30 degrees is pi over 6 radians. So I'm just going to count by 6s. 1 6, 2 6, 3, and so forth. Reduce the ones I can. So here, maybe we'll put, just so you can really see them, I'm going to put all these 30s in blue. I'm making it messy. So I'm just counting by 6s. Right here at 30 was pi over 6. 60 then would be 2 pi over 6, but that reduces. Forget about the pi, just think about the fraction. 2 over 6 is a third. So this guy is pi over 3. But we're counting by 6s. That was 1, 2 pi over 6, 3 pi over 6. Think about that fraction. 3 over 6 is a half. I already have that one. 4/6. That one reduces. That's 2π/3. So that was 4/6. This would be 5π/6. 6π/6. That's just pi. 7π/6. 8π/6. That one will reduce. 2 goes into 8 and 6. So that would be 4π/3. So that was 8/6. 9/6 I already had. 10/6 would reduce. 5π/3. 11π/6. And then over here would be 12/6, but that's just 2. 12 divided by 6 is 2. Notice that those are over 6. Those two are over 6. Over 3, over 3. The ones close to the verticals are over 3. The ones close to the horizontal are over 6. Now, a lot of times I'll ask students, draw me the unit circle, and they draw this, and they think they've done something. We haven't done anything yet. What I have in front of me is literally just converting angles between radians and degrees. This is not unit circle yet. We are nowhere near done. Now we're going to label all of these points here. Literally label the points with their x and y coordinates. We're in unit circle, so my radius is 1. That's why it's called unit circle. So every single point here, think about if I have a circle here, I've got some point here. This is 1. I've got some angle here. Then sine of that angle will be this y value over 1. Cosine of that angle will be this x value over 1. So each point on here will be the cosine, comma, the sine. Literally the x and y coordinates of that point. So the points that I'm labeling here, every point will be the cosine of that value, comma, the sine of that value. So this point here, that's clearly the point. I mean, just look at it. I've gone over 1, up 0. That's the point 1, 0. This point here. Now here's a trick. Here's a quick way to do this. Again, I don't have all this memorized. I use tricks. My sine values start at 0 and they go up. So I'm doing the second. I'm doing the y values. 0, 1/2, root 2 over 2, root 3 over 2, 1. The cosine follows the same pattern, but it goes backwards. It starts here at 0 and goes up as I go down. So 1/2, root 2 over 2, root 3 over 2, 1. So this is saying, like right here, this thing is saying that 30 degrees, the cosine of 30 degrees is root 3 over 2. And it's saying sine of 30 degrees, or pi/6 if we're in radians, is 1/2. That's the information we're getting out of this. If I wanted tangent, tangent would be sine over cosine. So I could extract tangent if I wanted it. Now notice, again, notice the pattern. The sine goes up, the cosine goes down. Here's another trick that a student taught me. If I put my hand like this, I'm gonna have to stand to do this. Each of my fingers corresponds with one of those angles. There's 0, 30, 45, 60, and 90. Let's say I wanted to know cosine of 60 degrees. That's this finger. I could put that finger down. Now it goes, starting from the left, cosine, sine. So look, I've left how many fingers I have left up. 1 and 3. Look at the tops. 1, 3. Root 3, but 3. What if I put this finger down? I've got 2 and 2. 2 and 2. If I put this finger on the 30-degree down, going from the left, 3, 1, 3, 1. So using this, you can see who goes first. There are only a few different numbers in here. These are the ones everybody gets backwards, the 1/2 and the root 3 over 2. That's where you're going to mess up. So those are the ones you got to be careful with. All the 45s are root 2 over 2. All the quadrangle angles, the 90s, are all 0s and 1s. The ones you're going to get messed up are the 30s and the 60s. Okay, so we're a quarter of the way done, but we're really almost done, because now I'm just going to take this same pattern and flip it over here. Look at all these x values. Think about that x value right there. That's a negative x value. I've gone backwards and up. So now I'm just going to rewrite all these. I'm going to go like this. Write the same thing, only now I have negative x values. Negative 1/2 root 3 over 2. Here and here. These go together. I'm just kind of flipping this over and making all the x values negative. And then here, make the x value negative. Negative 1, 0. Same thing down here. Now I'm going to flip down. Now I'm in quadrant 3. My x's and my y's are both negative. Look at that point. I had to, here's my origin. I went backwards on the x, backwards on the y. So I'm just going to take this and mirror it down. So I'm going to go same, same, same. Only now both x and y are negative. So negative root 3 over 2, negative 1/2. And just going straight down, instead of 0, 1, 0, negative 1. And then finally, this quadrant, I could either flip over or I can flip down. Over here, my x's are positive, my y's are negative. So all the first numbers will be positive, all the second ones will be negative. So I like to go like this. So same numbers, just now make positive, negative. So right here, 1/2, negative, root 3 over 2, root 2 over 2, negative, root 2 over 2. That one there, root 3 over 2, negative 1/2, and then I already have that one. This is unit circle, everything you see here. You should get to the point literally that you can redraw this entire thing in under a minute. Again, I'm going to show you another way using reference triangles that makes this unnecessary, but this is really a skill you should have. And then from here, we can literally just read off everything. So say I asked you for, oh, I don't know, cosine of 5 pi over 6. So I go to my angle, 5 pi over 6. Every point is cosine, comma, sine. That's the cosine. The answer would be negative root 3 over 2. What if I asked for sine of 330 degrees? So now I look at the degrees. I come around, here's 330, cosine, comma, sine, negative 1/2. And all of these, everything we have here is from our special triangles, our 30, 60, 90 triangle and our 45, 45, 90 triangle. That's where all this comes from. All right, now, if you asked me for sine of 330, I absolutely would not go through all this trouble of drawing out unit circle to answer one question. Reference triangles are your friends. Here it's the easy way to do all this. So let's do the one we just said, sine of 330 degrees. Here's what I would do. 330 degrees lives here. That's 330 degrees. I don't care about that. I want the reference angle. The reference angle always lives against the x-axis. I want this angle, not this one, the one against the x-axis. Well, if I've gone 330, 360 is all the way around, so this little angle in here must be a 30-degree angle. And then I know how to fill in a 30, 60, 90 triangle. Remember your 30, 60, 90 triangle, across from the 30 is a 1. I don't need any of this anymore. Across from the 60 is a √3, and the hypotenuse is a 2. Now you got to put in the pluses and minuses yourself. When you do reference triangles, you have to actually use your brain for a minute. Think about, look at that negative value there. That's a negative y value. So that's -1. And then sine is just opposite over hypotenuse. -1/2. Opposite over hypotenuse. Or another way, all students take calculus. I'm in quadrant 4. I know sine is negative in quadrant 4. I know my reference angle is 30. It's -1/2. I'm done.